The purpose of this video is to basically walk you through how I would go about matching the graphs of the functions that you see, the 6 functions on the top half of the page, to the 6 derivative graphs on the bottom half of the page. So the way I approach these kinds of problems is I'm going to start right here at top left, and I'm not even going to look at the graphs of the derivatives down below. I'm going to try to construct the graph of the derivative based on the graph of the function itself. This particular graph I can see here, this graph I can see it's a constant slope, and the slope is about 1. Okay, slope is about 1. Never is the slope equal to 0. And if I draw the graph of the derivative on this graph here, I would say since the slope is always 1, f prime must always be 1. Okay, so that's my derivative graph. And if I look down at the graphs below, I see that B is the only graph that matches that. F kind of looks like that, but F has a hole right there. And I know that the derivative does exist everywhere here, so B is the most logical choice. It's the only choice, really. All right, and then what I'm going to do here for the second one is I'm going to notice that I've got a horizontal tangent line to the graph of this function here, and that means that I have an x-intercept of 0 on my f prime graph. I also notice here that I've got positive slope here on the left-hand side of 0, so when x values are negative, I know that my f prime is positive. That was kind of confusing the way I said that. So to the left of this critical point, f prime is positive. Okay, let me say it like that. F prime positive here. But also f prime is approaching 0. Notice how the slopes get closer and closer to 0. That's another thing I'm looking at. And when I graph f prime, I have slopes that are getting closer and closer to 0. So my f prime is getting closer and closer to my x-intercept. Okay, and as likewise over here to the right of 0, I notice that my slopes are negative, so therefore my f prime has to be negative, and therefore my f prime has to be below the x-axis. And I look down there and all I see is that D staring me right in the face. D. It's got to be D. It's the only one that makes sense. Okay? And then we have so over here at the next one, top right, we've got, first thing I'm looking for is where the derivative is either equal to 0 or does not exist. So I've got a big hole right there when x is equal to 0, hole on my derivative graph. But I also notice that my slope over here is negative 1, and I see my slope right here is positive 1. And I'm just guessing, okay? I don't really need to be exact. Just guessing it's negative 1 over here and 1 over here. And so therefore, to the left of 0, my f prime has to be negative 1. So m on the slope on f is the f prime is the value of f prime on my f prime graph, and then slope of f, okay, so when x is positive, slope is 1. And that is A. Okay, it may have gone through that a little fast, but if you really think about it, f prime, the graph of f prime represents the slope of f. So the values of f prime are the slopes of f. So if the slope is negative 1, the value of f prime is negative 1. Okay? All right. Now let's look over here at this next graph, and this next graph is the one right here. I'm noticing here that I'm estimating the slope here to be 1. Again, the slope here is also 1. And so that means my derivative has a value of 1 everywhere except at x equals 0. Because at x equals 0, guys, we've got discontinuity in the graph of f. And a discontinuity means we can't have a derivative. So the derivative then, f prime, is always 1 except when x is equal to 0. And so I get a horizontal line, and that is f. All right. And on this next one, you can kind of cheat because you can see it's x to the third. And so f prime would be like x to the second. And I can see that that's going to be c. All right, but let's just say we don't cheat. Let's say we're doing this legitimately from start to finish. If I take a look at this, I've got horizontal tangent line right there at 0, so that means I have an x-intercept. That's the first thing I look for, where f prime is either equal to 0, in other words, horizontal tangent line right there, f prime is equal to 0, meaning that because the slope of the tangent line is 0. And then to the left of that critical point, I can see that f prime is positive. The slope is positive. Slope positive, that means that f prime is positive. But the slope is getting closer and closer to 0. And then over here, though, to the right of that critical point, I can see also that the slope is positive again. Okay, and the slope being positive again corresponds to the derivative being positive. And then notice that as x moves to the right, the slopes are getting bigger and bigger. That's why we can see the value of the derivative getting higher and higher. Okay, so as x goes from negative infinity to 0, the slopes of the tangent lines are getting smaller. And as x moves away from the origin to the right, we can see the slopes of the tangent lines are getting bigger, higher. Okay, therefore the f prime is getting away from 0 and getting higher and higher. And like we said, that would be C. Now don't be like I was when I was in school and just say, oh, there's only one left, and let's just pick that. Let's think through it. Okay, think through it, because what if you made a mistake somewhere along the line, and now you're going to catch your mistake here if you did make a mistake earlier, because you're not going to find the derivative graph to this one. All right, so it's not going to take long. We've got f prime, or sorry, slope is equal to 1. We see that f prime does not exist there. F prime does not exist. And then we can see the slopes here start at 0 and getting bigger. Start at 0 getting bigger. Okay, so slopes are positive, though, starting at 0. So how does that translate? When x is equal to 0, we have no derivative. But to the left, though, from negative infinity to 0, f prime has a value of 1. Okay, and then the slopes start out at 0 and then move to the right and then just get higher and higher. But again, the derivative doesn't exist there because it's a sharp point. So we have to have an open circle. But the derivatives start low, the values start low, and they go high. Okay, and yeah, that you can see is E. And then I back up and I think, did I get A, B, C, D, E, and F? I get A, B, C, D, E, and F. And so all are accounted for. Hope that helps. Don't forget, though, there is one more worksheet that I want you to fill out, and you're just going to bring that to class on Friday. For this video, it'll be tomorrow because right now it's Thursday. But anyway, thank you for being patient. My wife is happy, and you're happy, hopefully, and we'll see you tomorrow.